Visual, futuristic 3D animation of bridges, skyscrapers, dams, and tunnels forming on a digital blueprint gives welcome to Civil Engineering Edge, where we explore the greatest engineering wonders, breakthrough innovations, and the projects shaping our world. From megatunnels to futuristic smart cities, here you'll discover the edge of modern civil engineering. Epic visuals of Swiss Alps, tunnel boring machines, and dramatic drilling. Imagine carving a 57-kilometer path straight through the heart of the mighty Swiss Alps. A tunnel so deep 2,400 meters beneath the surface that no one in history dared attempt it before. This is the story of the world's longest tunnel, the Gotthard Base Tunnel. In Switzerland, engineers set out on one of the boldest construction projects ever attempted. Their mission: to reroute traffic and goods across Europe, bypassing the Alps not over them, but through them. A direct rail link that would transform transport forever. But building this engineering marvel wasn't easy. To succeed, engineers had to drill through some of the hardest rock on Earth. The machines, giants of technology tunnel boring machines taller than a 3-story building and longer than for football fields. Work continued around the clock, 24 hours a day, for 6 relentless years. But could they really stay on schedule? And what technical challenges would stand in their way? The Gotthard Base Tunnel project came with a staggering $10.3 billion budget. It consists of 2 parallel rail tunnels stretching 57 kilometers each, making it the longest tunnel in the world, outshining even Japan's famous Seikan Tunnel. But scale wasn't the only demand. The Swiss government required it to last at least a century, meaning every single material had to pass the strictest quality tests. And if that wasn't enough pressure, engineers also faced a timeline tighter than ever. So, how did engineers overcome these challenges? What secrets lie behind the success of the world's longest tunnel? Join us as we dive deeper into the extraordinary story of the Gotthard Base Tunnel, an achievement that redefined what is possible in civil engineering. The impossible task visual: explosions of rock, giant dump trucks hauling debris, workers inside hot, dusty tunnels. The Gotthard Base Tunnel wasn't just massive, it seemed impossible. If the project went over budget or fell behind schedule, contractors faced heavy fines. But even without those penalties, the sheer scale was overwhelming. Workers had to remove 24 million tons of rock from the Alps. That's enough material to fill 16 football stadiums. Visual: heat shimmering inside tunnels, exhausted workers wiping sweat, heavy machinery drilling through rock. Conditions underground were brutal. At depths of 2,400 meters, temperatures soared close to 50 degrees Celsius. Miners toiled in darkness, choking on dust, fighting for oxygen, and risking their lives every single day. This wasn't just a construction site, it was a battlefield between human ingenuity and the raw power of nature. Visual: geologists examining rock samples, drilling cores, mapping geology. To fight back, geologists took samples deep inside the Alps, identifying rock types long before excavation. Their findings determined how engineers would dig. In hard rock, massive drilling machines powered forward. In unstable zones, blasting was the only option. But when crews faced high-pressure, water-bearing rock, neither method was safe. The risks multiplied instantly. Visual: animated 3D cross-sections of tunnel designs. Single tube, triple tube, dual tube. The next challenge was design. A single large tunnel with 2 tracks might have been cheapest, but dangerously flawed. If a train broke down, it could block traffic or even cause a head-on collision. A safer option was a 3-tube system, like the Channel Tunnel, with 2 train tunnels and a central escape shaft. But this design was far too expensive. Visual: engineers discussing blueprints, animation of 2 separate tunnels connected by cross passages. Engineers finally devised a smarter solution: 2 parallel tunnels, 1 for each direction. Every 300 meters, cross passages connected the 2, giving rescue teams direct access in an emergency. Additional escape routes and to fully equipped emergency stations were built inside. This design balanced safety, cost, and efficiency, ensuring that the Gotthard Base Tunnel would not just be the longest, but also one of the safest tunnels ever built. Building the monster machine visual. Wide aerial shot of Swiss Alps gives transition to huge tunnel entrances with machinery arriving. In theory, this could be the safest railway tunnel ever designed. But theory means nothing until tested. Construction had to begin, and it began with the world's most advanced tunneling machines. Visual. Engineers studying maps, GPS satellites orbiting, digital overlays of tunnel path. Engineers plan to use two tunnel boring machines, one digging from the north, the other from the south. But here was the question. How could they guarantee the two machines would meet perfectly in the middle of a 57-kilometer tunnel? The answer was precision mapping. Engineers installed GPS receivers at both tunnel entrances and 3 critical checkpoints along the route, creating a digital guide with millimeter accuracy. Visual. Huge parts of TBM arriving by truck. Workers assembling massive machinery. Each TBM was a colossal beast over 400 meters long, weighing 2,700 tons, and made of 500,000 individual parts. Built in Italy and shipped to Switzerland, the assembly alone took workers 8 months. The most daunting challenge, the cutting head. With a diameter of 10.7 meters and a weight of 187 tons, it had to be lifted vertically and carefully placed into position. After 4 hours of tense maneuvering, the heart of the machine was finally locked in place. Visual. Giant steel blades turning slowly, then accelerating, sparks and rock fragments flying. At last, the moment arrived. The button was pressed and the tunnel boring machine roared to life. Powered by 30 hydraulic pistons delivering 5,700 horsepower, the cutting head advanced with a force of 26 tons. Every day, the machine chewed through 30 meters of alpine rock, carving history one rotation at a time. Visual. Conveyor belts moving debris, robotic arms installing tunnel segments, concrete injection filling gaps. But cutting rock was only half the challenge. Behind the TBM, a continuous train of transport units carried giant tunnel segments forward. Every 2 meters, work stopped for assembly. Robotic arms placed each segment with precision, sealing them with rubber gaskets to keep out water and toxic gases. To stabilize the tunnel walls, workers pumped in a fast-setting concrete mix, locking the structure firmly into place. Step by step, the Alps were giving way to engineering brilliance. Visual. TBM grinding through rock, massive conveyor belts moving debris. The tunnel boring machines were unstoppable each day, excavating nearly 2,000 tons of earth and rock. None of it went to waste. The debris was hauled outside, recycled, and reused. But lining the tunnel demanded something even greater, an astonishing 40 million tons of concrete. Much of it was produced from the excavated rock itself, lowering costs and conserving precious natural resources. Visual. Workers with drills, sparks flying, laser beams marking walls, yet the T-beams weren't invincible. In sections of soft or unstable rock, these giants were too dangerous to use. Here, engineers turned to traditional methods, drilling and blasting. Precision lasers guided the drills, while computers calculated the perfect blast pattern. Crews bored 80 holes, each more than 5 meters deep, and injected them with 2 harmless chemicals. Alone, they were safe, but combined, they unleashed a powerful explosion. Visual, rock face cracking, workers cheering, breakthrough moment with dust and light flooding in. On October 15, 2010, history was made. The final wall of rock fell, uniting north and south and setting a world record. After 11 years of relentless construction, the Gotthard Base Tunnel was complete, the longest railway tunnel on Earth, a symbol of human determination and engineering genius. Visual. High-speed trains racing through the tunnel transition to majestic aerials of the Swiss Alps, from brutal heat and crushing rock to groundbreaking innovation. the Gotthard Base Tunnel stands as a triumph of civil engineering. A project that rewrote what is possible beneath the Earth itself. Thank you for watching. Don't forget to like, share, and subscribe, and join us in the next video, where we uncover more engineering marvels shaping our world. Visual time-lapse of construction sites gives trains passing through Gotthard Tunnel gives fade into your channel logo. This was Civil Engineering Edge, bringing you closer to the marvels of construction and design that define our future. Don't forget to like, share, and subscribe for more deep dives into the world's greatest engineering achievements. Until next time, stay curious, stay inspired, and keep building the future. Like, share, subscribe. Civil Engineering Edge, exploring engineering wonders.